All right, I'm going to go over daily problem 108 and then I'll go over 109 right after, and I'll post 110's solution tomorrow. So from the description that was given, this is one way you could have drawn your circuit. The most important thing is the fact that these are all parallel to each other. The order doesn't really matter. It's a 9-volt battery with these 3 resistors. They're all in parallel. Here we go. So these are the things we need to find, just like the practice problems we've done. I'll start with equivalent resistance. Because these are all in parallel, we're doing 1/5 plus 1/13, plus 1/6. We add them and we flip it. What we end up with is a nice ugly number, of course, which is 173/390. We flip that, we get 390/173, which is approximately 2.25. Okay. Next thing I want to find is the total current at the battery. So anywhere out here. Okay. So total, we know Ohm's law. So current is going to be voltage over equivalent resistance. So we are doing 9 over that number, but I'm going to use this one so that I don't get any rounding errors. So we end up with a total current of like 3.99 or 4 amps. Okay, and then voltage drop. So there's nothing else going on, nothing else in series with the battery, which means that the voltage drop across each of these branches is 9 volts. They all have the same voltage drop. So we know that all of these are 9. Okay, and now we just need to do Ohm's law a bunch of times to figure out what all of those individual currents are. So I1 is going to be 9/5. I2 is going to be 9/13. And I3 will be 9/6. So what we end up with is 1.8 amps for this branch. We end up with about 0.7 or 0.69 amps in this branch. And that makes sense, less resistance on this branch, so it should have had a higher current, more resistance on this branch, so it should have a much lower current. That makes sense. And then 1.5 amps for the third one. And there we go.